Hello everyone. Here we are with another interesting session specially designed for you to be able to understand the world a little bit better. So let's begin with a very simple question. How are we all connected to the World Wide Web? WWW, as you may be knowing. Well, before watching this video, you must have connected your mobile device to the internet, right? Ever thought, where does this internet come from and how does this work? Now you would say that the telecommunication companies like Airtel, Vodafone, Idea and others provide this internet. You are right, but do these companies produce internet by some process, maybe some machinery in a huge industry? No, internet is not an automobile that can be produced in industries. Then where does this come from would be your next question. Let me tell you. We are all connected to the internet through a well-connected network of wires. You must be wondering, what? Wires? When I connect to the internet from my phone or laptop, there are no wires that I need. You're right, but the modem your phone or laptop connects to is the part of a big network of wires spread all across the globe, on land and even in the oceans. Imagine, you live in Saket area in Delhi. Then the wires coming from all the modems, from all the houses, offices, shops, etc. from Saket are joined together in one location. Then the wires from this location is joined with the wires from all other locations in Delhi. Then the Delhi wire is connected to the wires coming from all the states of India. And finally, the Indian wire is connected with the wires coming from the rest of the world. That's huge. What results is a huge interconnected mesh of wires popularly known as the internet. And this mesh is mainly consisted of wires called the optical fibers. An optical fiber is a flexible, transparent fiber slightly thicker than that of human hair. Yes, it is that thin. Now you must be wondering, what's so special about these wires that so many lakhs of kilometers of such wires are spread all across the world? Optical fibers offer an advantage of cheap and reliable long-distance communication like no other cable. Also, these wires offer very high bandwidth, which means higher data rates at absolutely no loss of content. Additionally, fibers are immune to electromagnetic interference, which is a problem from which metal wires suffer. You can think of it as the speed and quality of the online content that you watch or the online games that you play like Fortnite or PUBG. It is obvious that you would not want to watch an interesting video that buffers in half a day with half of the screen missing on an internet connection that costs 20 times more than your current cost. With metal wires, that's what you're gonna face. Let's find out why optical fibers are fast, reliable and so cheap. The answer is physics. Specifically reflection and refraction. Even more specifically, total internal reflection. An optical fiber is a cylindrical dielectric waveguide or a non-conducting waveguide that transmits packets of information along its length due to total internal reflection. What information? Good question, dear friends. Well, the information travels through fibers in the form of packets, which is controlled by the Internet Protocol. Let's understand this. Suppose you were to send 5 kgs of potato chips to a friend living in another town, what do you think would be a better option? To send all the chips in one bag or to pack the chips in smaller packets, each having a fixed quantity, just like the 20 rupees Lay's packets that you get in market? Well, chances of chips reaching in a better condition, that is without breaking or without falling, is when they are sent across in the form of smaller packets rather than sending them all together. The same is the case with information. It is easier to send and extract information with appreciably low losses when it is sent across as packets. Another interesting fact is that these packets travel at the speed of light, because light also is packets. It is not like the electronic movement in coaxial cables which possesses a limited speed. This is how optical fibers result in reliable and fast communication of data. So the next time you're binge watching on the internet, remember that the YouTube or Netflix video is not traveling as a video through fibers, but the video is broken down into smaller packets, and all these packets are thrown simultaneously onto the internet. When they reach the destination, that is you, they are put back all together as a full video. Other concepts of network architecture are beyond the scope of our syllabus and this video, but indeed, they are very interesting. Well, another interesting thing about optical fibers is how these signals, or maybe by now I should say the packets, travel across through these wires. Here's the answer. Signals propagate by total internal reflection, in which the incoming ray is incident on the surface with an angle greater than the critical angle. Well, I said it ray because I'm talking about light here. At this angle, the light ray is completely reflected without any loss, which means no light passes through or is absorbed by the surface. So the signals hit the co-cladding interface, bounce back and hit the co-cladding interface on the other side and repeats the motion throughout the length of the wire. Imagine all of this happening inside a cylinder. The physics involved in this fun concept is to shoot the packets at an angle greater than the critical angle. And voila! Isn't it cool? The light makes a zigzag pattern as it travels through the optical fiber. And because the cladding does not absorb any light from the core, the light wave can travel great distances. This is how you get global interconnection. The content is traveling across globe without any loss. Of course, one cable cannot connect the entire country or continent. This is why various coupling and fusion methods are used to connect wires from different regions. So when Jio recently proposed to deploy a completely new network of optical fibers for the launch of 5G, this is what they were planning to do. Do you realize how these basic phenomena of physics are the basis of such magical processes happening across us? Who knew that these mobile operators would be dealing with reflection and refraction through cables to offer us internet connectivity? But it is as simple as that. Let's just revise what we discussed till now. Reflection and refraction are two basic phenomena related to light. When reflection is caused, the light striking a surface bounces back. Total internal reflection is a special case of reflection where absolutely no light is lost to the environment and 100% light bounces back from the surface. This happens only at a certain angle of incidence, which is greater than the critical angle for the material. Now let's understand refraction, another amazing concept in physics. Let's take a simple example to understand this concept first. Imagine a person clicking selfies near the lake gets into trouble as he slips and falls into the lake. He doesn't know swimming. The lifeguard standing beside the lake rushes towards the person, but he runs until he reaches close to the drowning person and then jumps to save him. Do you observe the trick? Why didn't he directly jump into the lake to get the drowning man? Think about it. That is because he can run much faster than he can swim. The speed of a man is higher on ground than in water, obviously. That is why the lifeguard does not follow a straight line to get the person, because he wants to minimize the time it takes rather than the distance he travels. Light does the same thing. Because light travels slower in a medium than the empty space, it follows a path to minimize the time it takes to travel from one point to another point inside the medium. This requires the light to either bend or refract at an interface between the two materials. This amazing phenomena is called refraction of light. Refraction is the change in the direction of wave, or in simple words, the bending of wave as it passes from one medium to another, or from gradual change in mediums. You can observe this phenomena at home. Take a transparent glass and fill it halfway with water. Take any pencil and dip the pencil inside the glass. Now take a look of this glass from outside. What do you observe? The pencil appears to be broken, or in other words, appears to have changed its path as it enters the water. So when light passes from a medium with one index of refraction, say m1, to another medium with a lower index of refraction, say m2, it bends or refracts away from the imaginary line perpendicular to the surface called the normal. The exact opposite happens when the ray of light passes from the medium of lower refractive index m2 to a medium of higher refractive index m1, which is the case of this pencil immersed in water experiment, where air has comparatively very low refractive index as compared to water, and hence the pencil appears to have bent towards the normal. You can observe refraction in nature as well. Rainbow and twinkling of stars at night are all the consequences of atmospheric refraction. Did you know stars do not actually twinkle, but they appear to twinkle because of atmospheric refraction? Also, the rainbow is not a magic. Rainbow is formed by atmospheric refraction of sunlight in water droplets, and that's how you get the band of 7 colors spread across the sky after the rain. Well, a lot has been discussed about these amazing concepts. Physics becomes interesting when you relate the concepts with your real life. Physics is all around us. Whether it is gravitation or electromagnetism, everything is present around you. All you need is observation and knowledge. So I will see you in the next session with more such amazing content. Till then, keep observing and keep learning.